Right now, there's a voice reading these words in your head, not out loud, just in there, narrating, commenting, sometimes arguing with itself. Where is that voice coming from? Here's the thing. Physicists can explain how a star explodes 10 billion light years away. They can predict the trajectory of a particle moving at nearly the speed of light. They can describe what happened in the first fraction of a second after the Big Bang. But that voice, that little narrator sitting behind your eyes, we've got nothing. And Richard Feynman, arguably the greatest physicist of the 20th century, said something genuinely unsettling about this, something that most physics teachers never tell you. Stay with me, because this one is going to change how you think about thinking. Welcome back, legends. I'm Abdullah, and this is Curious Physics AU, where we take the biggest ideas in the universe and make them actually make sense. Today, we're going down a rabbit hole that sits right on the edge of physics and philosophy. We're talking about consciousness, the hard problem, the observer effect, and what Richard Feynman's famous intellectual honesty tells us about the limits of science itself. Let's get into it. Richard Feynman was famous for one thing above all else, and it wasn't just his Nobel Prize. It was his refusal to pretend he understood something he didn't. He once said, and I'm paraphrasing here, "I think I can safely say that nobody understands quantum mechanics." That's the man who helped build quantum mechanics, telling you he doesn't fully get it. But here's the quote that really matters for today's video. Feynman was once asked about consciousness, about whether physics could ever explain the mind, and his answer was brutally honest. He said something along the lines of, "We don't know what we are talking about when we say we have something to do with the subjective experience." Translation. Even Feynman admitted that the experience of being alive, the feeling of seeing red, or tasting Vegemite, or hearing that voice in your head, is completely outside what physics currently knows how to explain. That's not a small admission. That's one of the most brilliant minds in human history saying, this one's got us stumped. So, why? Why is consciousness so hard? Let me introduce you to something called the hard problem of consciousness. This phrase was coined by philosopher David Chalmers in the 1990s, and it splits the question of consciousness into two parts. The easy problems, and look, easy is relative here, are things like, how does the brain process visual information? How do we react to stimuli? How do we store memories? These are genuinely hard scientific questions, but they're solvable in principle. We just need better neuroscience. The hard problem is something else entirely. Here's a simple example. Imagine I show you a photo of the Sydney Opera House glowing orange at sunset. Your brain does a lot of physics. Light hits your retina. Photons trigger chemical reactions. Electrical signals fire through your optic nerve. Your visual cortex processes color, shape, contrast. We can measure all of that. We can see it on a brain scan. But here's what we cannot explain. Why does orange feel like anything at all? Why is there a subjective experience of warmth and color, not just a data readout? Why do you experience the sunset rather than just process it? That gap between the physical stuff happening in your neurons and the felt experience of being alive is the hard problem. And it's the reason Feynman and every honest scientist after him has had to shrug their shoulders. In philosophy, these felt experiences have a name: qualia. Qualia are the what it's like of experience. What it's like to taste coffee. What it's like to feel cold water on your skin. What it's like to hear a song that makes the hairs on your arms stand up. Physics can describe the mechanism. It cannot yet explain the experience. Now here's where it gets really interesting and a little bit wild. You've probably heard that quantum mechanics involves an observer, that measuring a particle changes it, that until you look at something, it exists in a superposition, multiple states at once. The classic example is Schrödinger's cat. You stick a cat in a box with a radioactive atom. If the atom decays, the cat dies. If it doesn't, the cat lives. According to quantum mechanics, until you open the box and observe it, the atom is both decayed and not decayed, and the cat is, weirdly, both alive and dead. Now here's the question that kept physicists up at night for decades. Does the observer have to be conscious? Because the word observer sounds like it means a thinking, feeling being, like you looking at the box. And some very serious physicists, including John von Neumann and Eugene Wigner, genuinely proposed that consciousness itself collapses the quantum wave function, that awareness is physically special. Feynman himself was skeptical of this. He didn't buy the idea that the mind had some magical quantum power, but he also acknowledged that the measurement problem, why and when quantum possibilities collapse into definite realities, was genuinely unsolved. The modern consensus is that an observer in quantum mechanics doesn't need to be conscious. It just needs to be anything that interacts with the system, a particle, a detector, a bit of air. You don't need a brain, you just need an interaction. But, and here's the spicy bit, that doesn't actually solve the hard problem. It just moves it, because it still doesn't tell us why a conscious experience arises from that interaction. It tells us that the maths works, not why it feels like something to be the person doing the measuring. Now, some physicists have tried to connect quantum mechanics directly to consciousness. The most famous attempt is the orchestrated objective reduction theory, or ORC-OR, put forward by mathematician Roger Penrose and anesthesiologist Stuart Hameroff. Their idea? Consciousness arises from quantum computations inside tiny structures in your neurons called microtubules. The pitch is basically quantum mechanics is so weird, superposition, entanglement, non-locality, that maybe it's the source of that mysterious subjective experience. Now, is this accepted mainstream science? Honestly, no, not yet. Most neuroscientists think the brain is too warm and wet for quantum coherence to play a meaningful role. Quantum effects get disrupted very easily by thermal noise, and your brain is a pretty chaotic, warm environment. But it's not been completely ruled out either. And the mere fact that serious physicists are exploring it tells you something. It tells you that the smartest people in the room are still scratching their heads. Feynman would have appreciated that. He loved a good unsolved problem. Let's zoom out and look at what physics can tell us. Your brain is made of atoms, specifically about 7 octillion atoms. That's a 7 followed by 27 zeros. Those atoms follow the laws of physics perfectly. Electrons obey electromagnetism. Molecules obey thermodynamics. Every chemical reaction in your neurons follows the same equations that govern chemistry in a test tube. At the atomic level, there is nothing special about the atoms in your brain compared to the atoms in this table. And yet, somehow, the arrangement of those atoms, or the staggering complexity of 86 billion neurons, each connected to thousands of others, gives rise to something that can look up at the night sky and wonder about the night sky. That's not just impressive. That's one of the deepest mysteries in all of science. The physicist Paul Davies once described it this way: the universe has somehow contrived to know itself. Through us, the cosmos is waking up and looking around. Feynman had a similar sense of awe. He once said that when you understand the science behind a flower, the cells, the chemistry, the evolutionary story, it doesn't make the flower less beautiful. It makes it more beautiful. That's the Feynman philosophy. Curiosity doesn't kill the wonder, it multiplies it. So here's the honest summary. Physics is extraordinary. It can describe the fabric of space-time. It can predict how a nucleus will decay thousands of years from now. It can tell you what the universe looked like 380,000 years after the Big Bang. But it cannot yet tell you why you're experiencing this video right now, why there's something it's like to be you, sitting there, listening to this. That's not a failure of physics, it's a frontier. And frontiers are exciting, because it means we're at the edge of the map. The part where the old explorers used to write, "Here be dragons." Feynman's real lesson wasn't just about physics, it was about intellectual honesty. He was the most celebrated physicist of his generation, and he was completely comfortable saying, "I don't know." That takes courage, more than most people realize. Because here's the thing, not knowing is not the same as not mattering. The question of consciousness is one of the most important questions humans have ever asked. And the fact that physics hasn't answered it yet doesn't mean it never will. It means you might be the generation that does. If you're an HSC or VCE student watching this, this is what real science looks like. Not just memorizing equations, sitting with a genuinely hard question and being honest about where the answers run out. That's what Feynman did. And it's why we're still talking about him 35 years after his death. All right, let's land the plane. Today we covered the hard problem of consciousness, the gap between physical brain processes and subjective experience. why the quantum observer doesn't need to be conscious. But that doesn't solve the mystery, the Penrose-Hameroff theory, and why it's controversial, and what Feynman's intellectual honesty actually teaches us about the limits and the beauty of science. If this one got your brain ticking, do me a favor. Drop a comment below with one thing you're genuinely curious about. Could be physics, could be consciousness, could be something completely left of field. I read every single one. And if you want more of this kind of thing, proper deep dives into physics for Aussies who actually want to understand it, hit subscribe and ring that bell. Next week, we're tackling something just as wild: why time only moves in one direction, and what thermodynamics has to say about why you can't uncrack an egg. Trust me, you'll never look at your breakfast the same way. Catch you then. Stay curious, legends.